In this session, we are discussing how navigation can be improved by AI. And our moderator, Carl Jeffrey, founding editor of Digital Ship, is ready to have a conversation with our guest speaker, who is connected here with us, Dor Raviv, CTO and co-founder of Orca AI. Hello, Raviv. We are waiting loads of questions from the audience. And I guess, Carl, on to you.
Okay, so what we're trying to do today, we're looking at new areas of digital technology and where there's big change going on. And now we're getting into AI for ship navigation, which can include using data together with cloud servers. Now, when we talk about AI for navigation, a lot of people think this means autonomous ships. And okay, it may mean that if you're going to have autonomous ships, you need a lot of AI, but that may be a few decades away. But right now, it can mean giving seafarers better seafarer situation awareness on board. So in navigation, we're looking particularly today at collisions and contacts. So I've got some data I found from Lloyd's List Maritime Intelligence Maritime Safety Report 2021, sponsored by DNV. They said that collisions are the third biggest cause of vessel casualties after hull and machinery damage and vessels getting wrecked and stranded. Collisions are 13% of general cargo ship casualties globally, 9% of bulk carrier casualties, 20% of tanker casualties, 30% of casualties with all smaller vessels, and collisions together with contact were the causes of a third of casualties for ro-ros and ferries. So that's what we're aiming at. How can we use digital technology to help seafarers? So Orca AI has got a maritime and a technology background. Their headquarters in Tel Aviv in Israel, and they've got offices in London, Athens, and Los Angeles. The company's raised $15.5 million funding and is working with ship owners, shipping companies, and oil companies. And we're going to hear from Dor Raviv, who's CTO and co-founder of Orca AI, and he's got a background both as an artificial intelligence algorithms engineer and a maritime navigation instructor and experienced skipper, which is a pretty rare combination of skills, but I'm sure you can see this is exactly what we need to get this project going. So I'd like to invite Dor to give his talk. Thank you.
So thank you both. Good morning, good afternoon, and good evening, everybody joining us globally in this time of pandemic. First of all, I wish all of us to go through this new Omicron wave and make sure that everyone are fine and healthy. We're going to discuss today basically about how artificial intelligence is being deployed on board on real use cases and real scenarios. We're going to drill down a little bit about the challenges of artificial intelligence. And we're also going to learn how you can look on an entire fleet's data in order to improve the overall safety of the fleet. So without further ado, just let me know if you can see my screen and I can start sharing my presentation.
Not yet.
Okay, so just a second, let me share my screen. Perfect.
Yeah, okay. That's right.
So the purpose of today's short presentation is basically to describe how artificial intelligence is deployed on board. And the reason or the main driver for this I took just two papers just from last month. Unfortunately, these images are pretty common today. The waters are more congested than ever. There is a global shortage of experienced crews on board. And one of the things that did not advance at the same rate of increase of ships today is basically the technology on board. So many crews, many captains, many people on board actually do have access to technology, great technology in their smartphones, in their laptops, but ship navigation basically stay the same. And this is one of the paradigms that we want to challenge and want to discuss today. So unfortunately, today there are roughly around 4,000 ship incidents annually. It costs us billions in annual cost. It's very hazardous to our planet. Not talking about oil spillages, etc. And these are things that are common today and happen any day now. Now, why these incidents occur? So basically, first of all, it's important to understand 90% of these incidents actually occur in congested areas. So near ports, near shore, less in open sea. And today's existing navigation tools are just not suitable for these congested areas. I was a Navy radar operator. And one of the challenges in operating radar safely are actually about making sure to correlate and respond correctly to the situation. But you always need some cover with the human eye to assess the situation eventually. On the left side here, you can see an image from a captain's log navigating through Singapore Malacca Strait. You can see how basically the sensors just produce a lot of noise, and they throw this noise on the operator, which basically leads to the fact that 3 out of 4 accidents today are caused due to human error. Now, how can we improve that? So safe navigation for ships is a big domain. It's one of the biggest challenges of the industry. But in Orca AI, we decided to focus on these 6 safety challenges or safety use cases. On the left column, there are 3 use cases for the ship. One, the fact that navigation through through congested waters and in low situational awareness means that ship navigation in congested waters is hard. There are many distractions due to many inputs that are creating confusion and uncertainty in the bridge. And there is no real effective onboard training for officers on real scenarios. And this is an inherent problem in the industry where crews actually change between 3 to 6 months, every 3 to 6 months. Now, on the right side, the right column, we identified these 3 use cases for the office. So when you look on a ship, you actually understand that it is part of a fleet. And there is no real time office visibility to monitor the near misses and the risk patterns for the shore side. Also, most of the shipping companies have their own policies. Now, these policies, the SMS, is not being enforced effectively, meaning that today's fleet manager should just speak with his captains, state to them how they should navigate. But the world is very vague, and it's not black or white. There are a lot of grays. And God forbid there is an incident. There are no real-time voyage records in case of incidents, which is easy to really understand what happened. And these are the domains that in Orca AI we decided to focus on. So for the crew on board, we have developed a real-time safe navigation platform. It increases situational awareness in congested waters. It reduces the human errors and reduces the dependency on humans when operating the ship. It reduces the workload as well. It basically helps everyone navigate in a more easy manner. Now, when we started to developing the technology, we actually understood the biggest problem today. So according to Colreg rule number 5, each vessel should basically perform all actions in order to avoid collision and use all available measures, mainly speaking, by the way, about hearing and seeing. Now, deep learning algorithms in the field of computer vision have really advanced dramatically over the past 10 years, and they are production ready. We use these deep learning algorithms to perform the common actions as the watchkeeper for the purpose of detection, tracking, sensor fusion, and classification of targets in real time. This data is automatically collected from the entire fleet and uploaded to Orca AI secure cloud. Now, collecting data from sea is a unique environment. Not all data is relevant for training these deep learning algorithms. This is why we created a patent-protected algorithm to upload data properly from ship to shore. Now, some of you may think that, okay, what's the problem? Open sea and open sky, you just need to detect the targets. But as mentioned before, the use case for the Orca AI on board is not open sea where you have less accidents. It's actually in these congested waters where things actually develop very, very fast and there is a big level of uncertainty. Now, these algorithms, they actually need to understand the context of what's going on. This is why our training paradigm or how we actually train the algorithms is taking a lot of inspiration from the world of maritime navigation, but also from the world of computer vision and deep learning, meaning that some targets that might look visually the same are actually very different in terms of navigation. Just in this example, you can see a dog chip over here and a sheep over here. Now, in order not to confuse the algorithms, these two classes or detections are actually the same chips, but they have a very different meaning for navigation purpose. Now, what the captain actually sees in the system in real time. So we talked about reducing overload. So it's an accumulation of sensor data from the ship, like the position, the speed of the ground, the gyro compass. Now on the image, he actually sees a real-time video streaming with image recognition or object recognition real time for all maritime applicable targets, from buoys to fishing nets to fishing vessels to navigational hazards and other ships. Now the system automatically detects and tracks them and classifies them, and under the hood, it creates a risk prioritization algorithm that actually highlights collision risks with other ships. In this case, the AI algorithm that is trained on multiple use cases understands that the vessel on the port side is actually in a collision risk, while the vessel that crossed our bow is actually not in a collision risk. It does that by projection of all the ship's sensor data on the same plane and start to calculating the risk per target. Now, the important thing to understand here is that the system actively actually detects targets and fuses all these targets with all these sensors in order to create the risk prioritization. And when the image is very cluttered, it has a lot of clutter, the image is very hard to understand how to navigate. The system actually highlights what's most important. And this is what we found to be most important for reducing the overload and reducing anxiety. Now, what else can we learn? So the system actually automatically records these near misses or these incidents, but it then we can actually create some more interesting insights according to it. So for example, sailing here in congested waters, the system automatically starts recording these near misses or boat crossing, dangerous boat crossing. It then uploads it to the cloud, where it's being analyzed by both machine learning algorithms and human labelers in order to produce the largest collision risk database in the world. This is what we have created here in Orca AI. You can see this video, for example, prioritizes the risk on the top right corner, highlights the risk, and upload this information for the captain and the office to actually investigate what happens. All these videos are recorded and saved automatically on board and also uploaded to the cloud. And I'll show you what we do with this information. Now, the system shines in highly congested waters. And I wanted to show here the use case of sailing in congested waters in South China Sea near fishing vessels. Now, when you look here on the top upper right corner, you can see all these AIS information of fishing vessels and fishing nets. And I wanted to show you how it actually looks like when the Orca AI system records this data automatically. So again, projected on the map, on the orange part, you can see our own ship fitted with Orca AI. And on the blue part, the blue dots, you can see other targets, either visual targets collected by the system or AIS targets. Now, one of these ships actually had AIS, so we knew what the name was. And you can see how it looks like when sailing through China Sea at night and having a near miss with one of those fishing vessels. Now, what these machine learning do in the cloud, they actually get access to all the recorded data from the ship, and they apply multiple filters and analyses in order to highlight for the fleet manager what is most important. And this is the next part of the system that I want to talk about. So after realizing that a system on board is crucial for safe navigation, we need to understand today that the shipping industry is also changing. As mentioned before, the waters today are more congested than ever. It took this number, almost 10% increase of number in the last 5 years of ships globally. Today, there is a big problem of labor shortages. Crews are younger and less experienced. And last but not least, today's world fleet is more connected to the internet than ever. Today is standard post-COVID pandemic, and there are many fleets today that start to unlock and understand the potential of data-driven decision-making. And this is exactly what we actually enable in Orca. So we upload these recordings of near misses to the cloud. We also upload the entire voyage data, high resolution sensor data, plus imagery data. So what can we learn? In this use case, for example, when looking on safety, we broke down a voyage from Galveston, from Houston to Antwerp. And throughout the way, we look, for example, on the speed over ground chart. And our machine learning anomaly detection algorithms highlight these speed drops automatically. Now, when we want to investigate why these speed drops occur, we actually couldn't find any reasonable answer to that. We found out, for example, that in this speed drop, the vessel dropped its speed from 15 to 1.5 knots for 3 hours in the middle of the North Atlantic Ocean. And when we highlight these and provide that to our clients, to the fleet managers, they actually learn about the risk patterns and what is going on in the fleet. Now, the way to enable them to access this data is via the fleet safety dashboard. Now, within the fleet safety dashboard, they have online access and they have full visibility to the safety events. They gain also access to actionable insights, mainly trends and benchmarks about their fleet, and it allows them to enforce the company policy. So how this the dashboard looks like, for those of you who didn't see it before. So basically, the fleet safety dashboard has a risk score per fleet. This risk score is pretty complex. It takes into account not only the occurrences of events, but also where these events tend to happen more and the context. So is it inside a port, open sea, near shore? Now you can see here in the dashboard that it actually summarizes and accumulates all these risk patterns. Let's say we want to investigate a specific collision risk event. So first of all, we gain access to seeing where and when and how many of these collision risks actually occur. You can see it on a map. They will also support to see it on maritime charts on ENCs. And then you can see all these events and all these information that describes these events, like the distance, CPA, TCPA, location. When pressed upon, the fleet manager can actually see the video recordings it was recorded. Now, we worked a lot on making sure that the system is highly reliable and uploads all data to the cloud, and it was a big challenge. To summarize, the shipping industry is changing. We can see it with our clients, and we can see what's going on about how safety managers look on data. Ship safety is critical for today more than ever, due to the fact that the oceans are more congested than before. And these AI-based navigation tools will become eventually a must-have on board every ship. Thank you for today. I hope you found this lecture interesting, and I'm looking forward to hear any questions you might have. Thank you.
Oh, that's great. Okay, so we'll now go to the question and answer part of the session. I've got some of my own questions, but we welcome questions from the audience if you want to put them in the Q&A box. Well, first thing, so when it's modeling or predicting where the ship is going to be, is it just motion, or are you looking at currents and weather and things like that as well? Or?
So because we want to be agnostic to other sensors and want to make sure that the camera system is also reliable on its own, we perform a lot of the algorithms on the image recognition itself. So incorporated in that is already everything on how the world actually changes. It doesn't matter if we do get a reading for depth or current or water speed, All that matters is how fast it comes towards you, if it has a constant bearing, etc. So these are kind of the metrics, the visual metrics that are important, very similar to how humans perceive safety in terms of they might not know all the conditions, but it's clear to us what is dangerous and what is not just by looking on the object.
So I've read a lot of stories about Mississippi Delta with a high water levels. So I guess that would just be modeled automatically because it would see how fast the ship was coming and extrapolate that.
Yeah, you just see that. Yeah, exactly.
Oh, and then for nighttime, I guess you're using the lights then at nighttime. Is that how?
So at nighttime, it's a combination of the day camera and the thermal camera, as seen before. Now, a lot of people actually ask us regarding what do you do with extremely low visibility conditions. Now, unfortunately, these technology, the camera sensor, they do not surpass their own capabilities, and eventually they will not surpass also human perception. So we have more resolution and pixels in our eyes than cameras. What's important to understand is that the cameras are able to actually process multiple targets simultaneously and prioritize the risk according to proper risk methods. And this is what's important to understand.
Oh, that's great. So there's a question from Sunday Ogundele, who's a seafarer in India. He says, but he's asking about crew who don't have experience, but they've still got to have the certification to, you can't use this without navigation skills. So supporting people with the skills. I don't know if you want to have any thoughts on, you already mentioned the shortage of seafarers.
Yes, so as mentioned before, currently our scope is to enhance safe navigation. What that means actually is that once we install Orca AI system on board, we perform proper training and then you get a certificate. But the system itself is very easy to handle. So it doesn't require any inputs from the user. You don't need to play with it. You don't need to set it up. It just works out of the box. And when you plug it on board, it just started to analyze the situation and prioritize the risks for you. It doesn't mean that it replaces ARPA. It doesn't mean it replaces ECDIS. It's not a path planning tool. It's not a navigation tool. It's a navigation aid to basically assist you in your decision making. So it's here to kind of conform and verify your own kind of understanding of the situation. So you have another system that makes sure that you are complying and understanding the situation as is.
Yeah, I suppose car driving is an analogy. So people can drive cars in very, very difficult, congested roads and a computer can help them, but it doesn't mean that an idiot can drive in a congested road. It's still an extremely difficult thing to do, isn't it? But
yes, it's designed for competent people on board, but it's there to help you navigate safer and reduce the workload, especially where it's most difficult, in the congested areas.
Okay, well, two more. Another question coming in. Raimo Waki, demands on the ship-to-shore communication, particularly if it's sending live video. I don't think I guess if the fleet manager system did have live video. So are you sending live video back to shore on this?
So fleet managers actually, from what we've learned, they don't look for live video. Ships navigate anywhere and everywhere. And you have, eventually in the office, you have people who come to work. What they are more interested in is rather than intervention in live events, basically harming the way the captain handles the situation, they prefer to look on the broader picture, on the trends, on the high level fleet trends and anomalies. They are less keen to actually investigate in real-time events, usually due to time constraint. And also, again, they trust the captains and it's fine. The way they trust the captains, okay. This is another tool to look on the fleet on a global scale and increases the overall safety.
Yeah, I've just looked up Raimo on LinkedIn. I can see his business engagement lead with Stena Reederei Group IT in Gothenburg. So I guess it's showing a lot of interest. Now, another question I've got for the fleet manager. I mean, how are they actually going to use all this in practice? I mean, I guess people always say league tables are a bad idea because you never know all the other situations. So if they're going to say, well, this captain's safer than this captain, that's quite a dangerous I don't know if you have any thoughts on how maybe your customers are already using it, how they're actually using it in practice. Do they ask the captain about specific things while they did this, or is that?
So one of the things that we've learned is that captains eventually get contracts to go on board and get the ship from point A to point B in the safest manner and in time, right? So they also have kind of an internal incentive to be safe. Now, what we've seen, for example, one of our clients, the captain called the fleet manager and said to him, hey, I had a near miss yesterday. I'm pretty sure that the Orca system on board caught it. Let me understand if you saw it as well. And the way that it goes from the ship back to shore to make sure that the shore knows about these safety events and vice versa, this is the most powerful thing here. So the captains actually use this in order to prove their innocence, or to prove that I did right, maybe someone else did wrong, and this is why you got this, but I'm a safe captain. And we are not actually, we don't have access to who the captain is. Only thing that we know is that an event happened, a specific time, a specific place, and this was the aftermath. And it's on the fleet manager to decide what to do with this information. Now, what we usually suggest to do, there's no shaming here. We look on patterns on a broader scale, meaning that, for example, if you see a recurrent near miss, a recurrent dangerous situations, you can either go back to your own SMS, to your own ship management policy, or talk with the captains. But on the other hand, for example, what we saw a fleet manager who actually analyzes all these events, learned that there's a trend that his LNG tankers are actually getting closer and closer to other targets. So he rang the phone, called all his captains and make sure that they know, for example, that in Malacca Strait, they need to comply with at least 2 nautical miles in the traffic separation lane, for example, to make sure that they don't surpass that. So it's kind of a two-way street here. The captains, they want to make sure that the shore knows that they are actually safe, and the shore wants to make sure that all captains understand the policy. And we even saw one company actually changing the policy a little bit. So for example, within ports, we saw that there are a lot of near miss events and a lot of near collisions. And we said to the fleet manager, hey, let's change the policy because the ships can't comply with it. It's just, you can't measure every time that another ship goes to 0.5 nautical mile from it. It just doesn't make sense. So we help these companies let's call it, improve their safety management policies.
Oh, so my colleague Fiona from Digital Ship is asking, is the algorithm able to identify different types of ships and objects? And why is this important? I guess because you want to know if it's a small ship or a big ship, I suppose. Is that
Yeah, so actually, it's very similar to what you say, but in Orca, we actually look on ships on other terms. So yes, first of all, the algorithm is designed to classify and understand different types of ships, but these are not AIS types. So it doesn't really important for the algorithm if it's a cargo ship or a ferry. What's important is how predictable this target is. So commercial ships, they have high predictability, meaning we actually know that they are driven by professionals, and they should drive in a certain manner. They should not cross your bow, they should not overtake you in specific areas. And then there are all the unpredicted ones. The fishing vessels, the sailing vessels, sometimes the ferries, they like to cross the shipping lane. So these types of targets are actually classified as unpredictable, and they have different weights in the risk prioritization algorithm, meaning that, for example, predicted ships would be highlighted a little bit afterwards because the algorithm always kind of tries to make sure that he knows that this ship is actually not posing a true risk to your ship. It's actually doing its work as it should.
Oh, and in terms of the AIS plus the video, do you want to how do these interact? So you've got a subscription to one of these global satellite AIS databases, I imagine, but somehow that's getting sent to the ship, and it's using the video data together with the AIS data, is it, to work out the?
So actually, maybe I did not stress it enough. The system actually connects to the navigation sensors on board. So it doesn't require any cloud, any connectivity at all to operate. The system is on premise and completely offline. So all the AIS information it gets, it's from the ship. It has a special engine within it, the software itself, to upsample AIS data, synchronize that to the image, and then fuse it to the visual targets. So this is all performed in real time on board.
Okay, but the prediction is based on the video, the prediction of where it's going to be.
The prediction is based on the video, yes.
Wow. And how does the crew actually use it? I mean, they've got this equipment they've got to have for regulatory reasons, the radar and the ECDIS. So I guess this is another box next to it. I guess the captain can pick which is most useful to use at any time, isn't it?
Yeah, so basically we propose different alternatives for installation. The most common one is a 24-inch touch display on the bridge. And what most captains actually like is a tablet. They can carry it with themselves to the cabin. And in the tablet, there is a mirror of the system. So they can actually see from their own cabin what's happening outside and get all these insights in real time for the cabin.
Wow, oh, that's fantastic. Yeah, no, I was writing up an incident report in the Mississippi Delta of a tanker that hit an oil platform, and he got very confused about different things happening and a lot of fatigue. And I guess something like this would have made it very clear, because there was so much information overload at the time, I think, and something like this would say you're about to hit something 5 minutes before, and would have been incredibly useful, I think, wouldn't it? And
exactly, yes.
Yeah, oh, that's fantastic. Well, there's no more questions. I don't want to know if you want to give any closing thoughts, or if there's somebody from a shipping company is interested in trying this out. Are you at the pilot stage, or is it a product to sell? I don't know if you'd like to, or they contact you.
Yeah, so the system today is in product grade, meaning that you can go and contact us and buy this product for your ship and for your fleet. We have an amazing team of customer success managers. They actually your account executives, meaning that once a fleet actually installs Orca AI on board, they get access to data analysts who analyzes their data. They get access to the dashboard. They get access to training materials. We perform bi-weekly calls with the captains, making sure that everyone understands how to use the system. So the system today is in a state where we actually have a big team to help you go through the transition towards a more digital navigation. And you can contact us and you can check out our website, orca-ai.io. And thank you very much for having me.
Yeah, you don't want to give a ballpark price, or is that for negotiation or private discussion?
So the model itself is very similar to a subscription model, and this is why what's also new in the industry. I won't disclose too many details, but it basically means that you have access to the system on board and system in the cloud. And upon your request to specific features, we can build a model around that. So this is how we use it. You don't buy the hardware, we basically lease it to you, and you get the capabilities. And if something breaks down, we make sure to replace it, so it's not on you. And we have a global support team that's basically installers all over the world that can support you 24/7.
Well, that's fantastic. Well, it looks like it's a solution to a big problem that the shipping industry has. So I guess hopefully there's be a lot more interest in this kind of thing. So yeah, thank you. So I shall pass back to Vida for the closing words, and we'll see everybody tomorrow for our vessel performance sessions. Thank you.
Thank you.
Thank you. So this session might have seemed the most futuristic in our today's program. Thanks, Dor, for explaining how Orca AI works and how it's used by your shipping clients today. And this conference is a New Year's gift from Digital Ship and our sponsors, Sankere, Cordell, Beaumont, and Orca AI, to facilitate dialogue on management of digital technology in shipping today. So keep an eye on our event schedule, on our online platforms, and we hope we'll see you tomorrow and in the future. Goodbye.
Bye-bye.